not really an experiment. It's not really a lab either. But I'm going to take this opportunity to introduce you to a little bit of the physiology of digestion. We mostly did anatomy earlier in the week. We'll talk about nutrients here today. So nutrients are chemicals from the environment that an organism needs to survive. They supply energy to fuel metabolic processes. Remember, carbohydrates provide the energy for making ATP. They also provide building blocks for producing the molecules that the body needs, proteins in particular, but fats as well. And they come in two different classes. They are the macro and the micronutrients. Now, at first glance, that might look like the size of the nutrient. It's not the size of the nutrient, it's the amount of the nutrient that an individual needs. So a macronutrient is required in large quantities, things like carbohydrates, lipids, and proteins, while micronutrients are required only in small amounts, and those are things like vitamins and minerals. There are some that are considered essential. Those essential ones cannot be synthesized in the body. At least not in sufficient quantity, so they have to be brought in by diet. We'll start with carbohydrates. Carbohydrates are organic compounds. They're composed of carbon, hydrogen, and oxygen, and an organic compound is one that contains carbon. Sugars and starches are included among carbohydrates. Their energy is held in the chemical bonds, and that energy is used in the process of aerobic respiration to be transferred to ATP, and that ATP is used to power individual cellular reactions. Sources of carbohydrates can come into the body in the form of polysaccharides, which are complex. They are the starches we find from plant foods or glycogen we get from meat, or they can come in as simple carbohydrates. Disaccharides, those are double sugars, and those are our common table sugars, common food sugars like milk sugar, lactose, cane sugar, sucrose, beet sugar, molasses. Or they can be simple sugars or monosaccharides like we find in honey and fruit. Digestion breaks the complex carbohydrates into monosaccharides that are small enough to be absorbed through the digestive system. Cellulose is a very complex carbohydrate, one of the polysaccharides, but we don't have the enzymes to break down cellulose, so it's not digestion, but it is important for the health of our digestive system. Cellulose would be found in leaf matter, stems, tree bark, trees themselves. So different monosaccharides are absorbed from the digestive tract. The major ones would be fructose, galactose, and glucose. Those are all actually isomers of each other. Glucose is the most common cellular fuel, oxidized in glycolysis, and the other ones are converted into glucose by enzymes in the liver. So starches give us glucose, sucrose gives us glucose and fructose, two monosaccharides. Maltose gives us 2-glucose, and lactose gives us glucose and galactose. Those monosaccharides are either going to be used in respiration, when they will be converted to carbon dioxide, water, and the energy transferred to ATP. They may be used to store glucose for future use, in which case they will be made into glycogen. And in the same line, they may be used to create fats, which can be used for future use. Carbohydrates are the primary source of fuel for cell processes, and the need for carbohydrates is going to vary with individual energy requirements. We do have some minimal requirements, or we don't know the minimal requirements. However, it is likely that somewhere between 125 and 175 grams a day is necessary. The average diet in the United States has well over that, 200 to 300 grams a day. Lipids. Lipids are also organic compounds. They include fats, oils, fat-like substances, such as phospholipids and cholesterols. They supply energy for cellular processes when they are converted to glucose or small molecules, but they also serve as building blocks for structures, especially cell membranes. Most common dietary lipids are fats called triglycerides. They are composed of a glycerol molecule with 3 fatty acid tails attached to it. Triglycerides are found in plant-based and animal-based food, and they include saturated fats. Those are usually foods of animal origin, meat, eggs, milk, and lard, but also in palm and coconut oils. There are no double bonds between the carbon atoms in the fatty acids, and those are associated with an increased risk of cardiovascular disease. Unsaturated fats are found in seeds, nuts, and plant oils. They contain one or more double bonds between the carbon atoms. Monosaturated fats are the healthiest for our diet. Cholesterol is abundant in liver and egg yolk. There's some in whole milk, butter, cheese, and meats. It's not found in foods that originate in plants. Lipids are used to make phospholipids, cholesterol, and fats and triglycerides. They have a variety of functions. They maintain our energy supply. They contain more than twice as much chemical energy per gram as carbohydrates or proteins. More than twice as they're broken down into glycerol fatty acids. In order to release that energy, those molecules go into the Krebs cycle, just like glucose does. Liver can convert fatty acids from one form to another, but the liver cannot synthesize certain fatty acids. Those would be called essential fatty acids. They would include linoleic, and that has to be obtained from the diet. Lipids can combine with proteins to form lipoproteins. Lipoproteins are classified based on how dense they are. VLDLs, or very low density lipoproteins, have a high triglyceride content. LDLs, low density lipoproteins, have a high cholesterol content. And HDLs have a high protein content. The liver is going to control cholesterol level. It's produced by the liver and released into the blood, and cholesterol is used for many things, including making bile salts and excreted in the bile. And it also is an important component of cell membranes. The lipid content of the human diet varies widely. The American Heart Association advises that we don't go over 30% total daily calories from fat. People have different requirements based on their stage of life and their activity level, and fat intake has to be sufficient to support the absorption of fat-soluble vitamins. Proteins consist of chains of amino acids. They have many functions. So you talked about this before. They are the workhorses of the organism and of the cell. They include building proteins. There are structural proteins, enzymes, hormones, antibodies. Many of the things we've discussed and will continue to discuss this year are proteins. Proteins are first broken down into amino acids. The nitrogen groups are removed through deamination. Nitrogen groups react to form urea, which is removed by the kidneys, and the remaining deaminated portion of amino acids are decomposed in various pathways with things that will fit into the citric acid or Krebs cycle. However, we do not generally want to use proteins for energy source. That's a last resort. That indicates a starvation diet. Foods that contain proteins include meat, fish, poultry, cheese, nuts, eggs, milks, and eggs. Legumes, beans, and peas contain less proteins. The body needs the 20 common amino acids. 12 of those can be synthesized by the body, so they are called non-essential amino acids. 8 of them can't be synthesized, so they are called essential acids. All 20 of them have to be present. You don't start making a protein unless all the amino acids necessary to make it are present in the cell and ready to be used. And essential amino acids are not stored in the body. So the 8 essential amino acids that can't be synthesized are shown here with an E next to them. That would include isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan, and valine. So a complete protein is one that contains adequate amounts of all 20 of those amino acids, whereas incomplete don't contain some of those, and that tends to be an issue with plant-based diets. There are certain combinations of plants that will help give an adequate supply. Beans and rice together is a good example to get so that you don't lose out on any essential amino acids. In a healthy adult, protein is built up and broke down, and proteins contain nitrogen. So overall gain should equal the loss, and that gives you a state of dynamic equilibrium. Proteins have a high percentage of nitrogen, and that equilibrium leads to the nitrogen balance, and that's a measure of protein turnover in an organism. So a negative nitrogen balance would develop during starvation, whereas a positive nitrogen balance would be present in a growing individual, whether that be children, women who are carrying a baby, or even athletes in training. Besides supplying essential amino acids, proteins provide nitrogen and other elements for non-essential amino acids, contain certain non-protein nitrogenous substances. Dietary protein intake varies according to body size, metabolic rate, nitrogen balance. Typically, the daily protein intake is recommended to be about 10% of the person's diet. Most people should consume between 60 and 150 grams a day. Deficiency of protein leads to tissue wasting, decline in plasma proteins, and that can result in decreased plasma osmotic pressure, causing nutritional edema. So here are those 3 major ones: carbohydrates, lipids, and proteins. Energy expenditure: those carbohydrates, fats, proteins supply energy for metabolic processes. First carbohydrates, then fats, last resort protein. Deficiencies can cause us to consume our structural molecules, and that can lead to death. Excess can lead to obesity, which is damaging to health. So we talk about the energy value in foods as the amount, as calories. Calories are the amount of potential energy found within a food, and content varies. So carbohydrates typically have 4.1 calories per gram. Proteins about the same. Lipids almost twice that, 9.5. Our energy requirements are reflected in our basal metabolic rate, which is the rate that body expends energy under resting or basal conditions. It primarily reflects the energy needed to support activities of organs. It will vary with gender, body size, body temperature, thyroid hormone activity, and maintaining the BMR is the body's greatest expenditure. We need to maintain BMR, support muscular activity, maintain body temperature, and growth in those individuals that are growing. So just a couple of examples. Walking up the stairs is 1,000 calories per hour. Sitting at rest is 100. There are lots of very important ways to burn calories. And that leads to an energy balance. When caloric intake equals caloric output, that both body weight would remain constant. Otherwise, it would go up if you are putting in more energy than you are putting out, or go down if you're putting out more energy than you're putting in. And I'm not going to get much into desirable weights. You look at me, you probably know I am not at a desirable weight, but the desirable weight is not always equivalent to a healthy weight. But there are some clinical things you need to be aware of and should be aware of and use when you are making judgment calls for yourself and your family. The body mass index is one way to do it. It's a very common way to do it, and a person's BMI is either underweight, normal weight, overweight, or obese. If your BMI is exceeding the desirable weight by 10 to 20%, so your BMI of 25 to 30, you're considered overweight. Defined over 20%, a BMI over 30 would be considered obese. And obesity is more correctly defined as excess adipose tissue, excess fat. So probably the vast majority of people we know using just this formula would be classified as obese. Adults, I guess I should say. So there are charts where you can calculate what it is. It's based on your height and your weight in pounds. It does not take into account what kind of weight. Muscle weighs more than adipose tissue. There are some issues with it that you'll learn about in your nutrition classes, but in general, it's a good way to quickly assess a person's healthy weight. So almost a third of adults are considered obese, and that can be treated with diet and exercise. 1 pound requires you to burn an extra 3,500 calories. So if you think back to the earlier slide, that's about 3 hours climbing stairs. There are some drugs that will help with appetite control. Some of them have shown to be harmful. Surgery, there are 3 types of bariatric surgery that can be used to treat obesity. So with appetite control is under the control of hormones. Some of the important hormones are insulin, leptin, neuropeptide Y, and ghrelin. They all have varying roles, and they are all produced by different organs. Vitamins are organic compounds that are required in small amounts for normal metabolic processes. They are essential nutrients. They cannot be synthesized in adequate amounts, at least by the body, and they are classified as to whether they will dissolve in water or fats. So fat-soluble vitamins would include A, D, E, and K. Water-soluble would be the B vitamins and vitamin C. There's a few facts and fallacies, and again, I'm not going to go into this very much, but I will walk through this table. More vitamins the better. That's not entirely true. Too much of a water-soluble vitamin means that gets excreted in the urine. It's not really a problem, but you're peeing away the money that you are taking on vitamins. Too much of a fat-soluble vitamin, on the other hand, is stored in the body and can be harmful to your health. A varied diet provides all the needed vitamins. That may be true if you have a well-balanced diet, but not necessarily just a varied diet. Many people do benefit from vitamin supplements, and that's especially true for pregnant women, breastfeeding women, people who are using those vitamins more than just the average individual. Vitamins provide energy. Vitamins do not directly supply energy. They are not converted into carbohydrates and used in the Krebs cycle to make ATP. But they are used in the process of the Krebs cycle, so they do assist in that sense, but they do not provide energy. Fat-soluble vitamins dissolve in fat. They're influenced by the same things that affect lipid absorption. And they would include A, D, E, and K. I won't walk through this table with you. It's in your book. Water-soluble vitamins, B vitamins, vitamin C, do become decomposed during many cooking processes. B vitamins are essential for normal metabolism, cellular metabolism, and they are found in the same foods, so together they are known as B complex vitamins or vitamin B complex. And here are the water-soluble vitamins, although I do not see vitamin C on the table. These are the B vitamins, and I'll let you go through that on your own. And here is the rest of the B vitamins along with vitamin C, also called ascorbic acid. Minerals are inorganic elements. They're not carbon-based. They're metals in many cases, usually extracted from the soil by plants, and then we get them by eating the plants, or plants that ate the food that animals that ate the plants. They make up about 4% of our body weight, concentrated in our bones and teeth, and that would be calcium and phosphorus. They're usually used as parts of organic molecules. There's an iron in hemoglobin, you remember, that helps us carry oxygen. Some of them are important ions within the body. They have roles in muscle contraction, nerve impulse, blood coagulation, pH regulation, some things we've already covered. And there are homeostatic mechanisms that regulate the concentrations of minerals in our body. Mineral toxicity is an issue. Too much of a mineral from overexposure can lead to problems. The major minerals are, even though they're called macro minerals, they only account for less than 0.05% of the body weight. Would include calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, and most of those are calcium and phosphorus. Calcium excess can lead to kidney stones. Sodium excess can lead to hypertension and edema. The trace elements or microelements would include iron, magnesium, copper, iron, iodine, cobalt, zinc, fluorine, selenium, and chromium. You have tables to go through what they are. They are very low concentrations, but they are still important. They're still needed. So again, dietary supplement, I'm just going to say proceed with caution. They're not classified as food or drugs. Sometimes there's evidence to support that they help. Other times they're sold with absolutely no evidence at all. So when you are asked to go to a physician, you will be asked to bring your medications in many cases or list them, and you should include in that list any dietary substances, dietary supplements that you take. I am not going to tell you how to be a healthy eater. The MyPlate, the USDA that you learned about in high school and you will learn about in your nutrition classes, is a great resource. Just quickly, some types of vegetarian diets would include vegan, ovo-vegetarian, lacto-vegetarian, lacto-ovo-vegetarian, pesco-vegetarian, and semi-vegetarian. And each of those has benefits espoused to it, but there are risks that go with them as well. Balanced diet, well-balanced diet is a good diet. There's MyPlate. I'm not going to go into nutrition in the athlete. You should read it over. Malnutrition is poor nutrition that results from a lack of essential nutrients. Could be undernutrition or overnutrition. The causes of malnutrition are typically lack of food availability or lack of good quality food. Sometimes taking too many supplements can lead to malnutrition. So we can have a primary malnutrition, that is from the diet alone, or secondary, in which makes the individual not absorb the food correctly. We can live for about 50 to 70 days without food, but during that process, the body will begin to digest itself. And I won't go into each one of those common nutritional starvation disorders. Over our lifespan, our daily requirements, our daily BMR changes. And I'm going to leave it at that. All right, so that is a pretty good overview of nutrition to complement our talk about the digestive system. There'll be an assignment posted with this. Do the assignment, please. It will count as homework for the lab. Thank you, and I will see you Monday.